Hi, welcome to LeetCode. In this video, we discuss LeetCode problem 2825. Make string a subsequence using cyclic increments. So you are given two zero-indexed strings, string 1 and string 2. So in an operation, you select a set of indices in string 1, and for each index I in the set, increment string 1 comma I means ith index to the next character cyclically. That means A will becomes B, B becomes C, and if it is Z, then it will become A. So return true if it is possible to make string 2 a subsequence of string 1 by performing the operation at most once, this operation at most once, and false otherwise. So suppose for this example 1, the string 1 is A, B, C, string 2 is A, D. So what actually indices, first of all, we choose to cyclically increase that indices. So suppose first of all this A is equal, next is D. We want at least C or D. If it is C, then I can actually cyclically increase that. D, if it is I do not need to increase that, it will be automatically matched. So I'll check after A, is there any character out of this C or D? Yes, C is present. So this section is say that this actually we can make string 2 as subsequence in string 1, correct? Similarly for example 2 also, string 1 is ZC and string 2 is AD. So first of all, first character is A. So what character actually should be placed from string 1? It will be either Z or A. If it is Z, then actually we can call this operation like that cyclically increase, that will actually increase by from Z to A. So why not any other X, Y? Because we can perform this operation only once at most, 0 or at most once. So that's, if it is 0, then it has to be same to A. If it is at once, then character will be Z. So that's, I'll check, is there any character with Z? Yes, Z or A. Yes, Z is present. Next character is from string 2 is D. So what should be the character from string 1? It will be either C or D. So is there any character C or D? Yes, C is present. So that's why here also the answer will be true, correct? So what is the observation for this? So first of all, the string 1 length should be greater than equals to string 2 length, correct? This is the first observation. Next, the subsequence we are choosing from string 1, subsequence subsequence from string 1, that length will be equal to string 2 dot length of the string 2, correct? This is clear. Now what actually can brute force approach we can think from this actually conditions. First of all, generate all possible subsequences from string 1 of length string 2, correct? Because the subsequence ultimately from string 1, the length of that will be equal to the string length of the string 2. So that's why, what is the brute force approach we can actually think? That first of all, generate all possible subsequence from string 1 of length s2 dot length. So suppose we have a string 1 as A, B, C, D, and string 2 is A, B. So the string 2 length is 2. So our subsequence from string 1, that length should be 2 also, same. So what we'll do, first of all, generate all possible subsequence from string 1 of length 2. So it will be AB, it can be AC, AD, then I'll generate BC, then BD, then CD. Cut. This is all possible subsequence of length 2. You can check. Okay, now what we'll do, I will compare with this string 2, that is there any string that is actually ultimately like string 2 equal to string 2 or not. Like here actually it is matching, so that's why I can actually return true from here. If none of this is matching, the extra condition is I will check that the value that actually is present, that actually difference is 1, the character value difference. How? Suppose this is actually C, D, E, F, string 2 is E, F. Now none of this actually subsequence that we have generated is matched. Now what actually you can do, we will compare with C, D, E, F. There is no E, F, so it will be ultimately, suppose the string 2 is C, E. Okay, so this is the string 2, new string 2. Now we have generated the all possible subsequence of length 2 from string 1. This is all possible subsequence. Now what will do, I will do that I can actually first of all I can actually do directly, we can match the correct character. Current character is C, I will directly match this. Okay, if it is not matching, then what I will do, the character difference, the position difference, because I can actually increase only once, so the difference between C and A, it should be 1 or less than equal to 1. 0 means matched, 1 means I can actually increase, I can actually equal that character by calling that operation. Next for B also, like B, this is a B and next character is E, E minus B, similarly less than equal to 1. The clear. So I'll check what is the difference between C minus A, it is actually 2, that actually not greater than equals to 1, so that's why it is false. We can't actually equal this string to this string CE. This is guarantee, because the we have to perform this operation minimum twice, so that's why this is not true. Similarly for this AC, so AC and the string 2 is CE. So first of all, this character I will actually try to match. So what is the difference between A and C? I'll check. A and C difference is A minus C. The difference is 2. Again, not less than equal to 1. So we can't actually convert this string to equalize. Next string is AD and string 2 is CE. So equal, no possible, A and C again. So any one of these character is not possible to the target node or target character. That's why we will not be able to. Next is BC and this is CE. So this is possible, B to C. I can actually convert this, because if I call the operation once, then we can convert C to B to C. Next is C and E. Difference is what? 2. So that's why we can't convert this character only. So that's any one of this is false, so then actually can't convert this. Next is BD and CE. So BC, we can convert this. DE, difference is less than equal to 1, correct? DE minus D, difference is 1, so that's why we can convert this. So both character actually, all the character actually we can convert this, so that's why here actually we can return true. Okay, so you can check for this, I can actually convert this B to D. This is clear. Example and brute force approach also clear. Like first of all, generate all the possible substring, then actually compare each that subsequence or a string of length that particular. Okay, now how can I actually optimize this? So here actually what will time to study? To generate all possible subsequence of length L, suppose L, we have to actually traverse like each character we have 2 options, each character, like it will be part of the subsequence or not part of the subsequence. So if there is suppose n character, then times will be 2 to the power n, correct? To generate all possible subsequence, so that's a 2 to the power n to generate all possible subsequence. Next is, suppose we have generated suppose n1 number of subsequence. Okay, now for each subsequence we have each newly created string, we have to compare that character by character. So length will be again L. Okay, so n1 into L, because n1 is number of the string we have generated. Here actually n1 is how many string we have generated? 1 2 3 4 5 6. Here actually n1 is equal to 6, and for each string length is 2, so we have to compare character by character. Here you can check. So here actually time constant will be to n in n1 into L. So again it will be n square, correct? So that's why this will give time TLE. Now how can we optimize this? Brute force approach clear? If you have any doubt, any suggestion, you can comment on that. Now next is how can optimize this. So we have to like equalize the subsequence from string 1 and the string 2. So A, B, C, D, E, and we have actually have E, F. This is string 2, this is string 1. Now how can actually optimize this for this situation? So if I do the left to right traversal for those both the string, so first of all our current character is E for the string 2. So from string 1 what character I have to choose? First of all, because this is subsequence, so first of all first character should be equal to D or E. It is guaranteed that I have to choose D or E. So I'll check where actually I getting first D or E. So I'll check, okay, this is not D or E, this is not D or E, this is C, not D or E, this is D or E, correct? So I'll choose this character, okay, and I have already matched this. How actually match this? Because D or E both equalize that, I can actually convert this target character E, correct? So that's why I'll choose that and go to the next character. Next target character is F. So now I can't take any character from this side because this is subsequence. The next character should be from the right side of this current character D. So next character is E from string 1. So I can actually convert to F. So yes, because for F, if I call this operation once, so I can actually convert this. So this is DE. So that's how you can check whenever we reach the end of the string 2. That means we have found all the characters sequence by sequence. Character means like we can actually convert this either, or we can actually directly match the character, right? So that's why whenever we reach the end of the string 2, we will return true. That means we have found a match subsequence, else we will return false if we are not able to reach the string to end. Like it may be possible that only we have ABC and string 2 is GH. So first our target character is G, so we have traversal from left to right, we are not getting any Z, and we have reached the end of the string 1, but our string 2 pointer is still trying to find out G, any character of G. So that's why we will return false for this situation, correct? This is clear. So what is the approach? Approach is clear. Like we will take two pointer, one is pointing to the string 1, another is pointing to string 2. So suppose I and J, I pointing to the starting of the string 1 and J is pointing to the starting of the string 2. So our current target character is this S2 of J. So from string 1, I will check is there any like we will traverse left to right, that is there any character that is matched with this character, or difference is 1. So that time what will do, I will actually mark that, okay, I have found a matched, go to the next target character, okay. In this way, whenever I reach the end of the string 2, I will return true. If I have already reached the string 1 end, that means we have not found any matched, so that time return false. This approach is clear. Like this is subsequence, that means our order should be same, like A, B, C, D, and our string is suppose BD S2 and this is string 1. So it is always mandated that whenever I found B, the D will be at the right side of this particular character. Like it not possible that A, D, B, C, this is a string 1, then we are saying that this is a subsequence of this, because B is present on the right side of the D. The subsequence means sequence should be maintained, right? So that's why this is not obvious. That's why this order actually helps us here. Like whenever we found a character, matched character, I will go to the next target character, and similarly for we are trying to find the any match character from the string 1 from left to right, because it is guaranteed that the next character will be present on the right side of this. So now go to actually code. So we have taken 2 pointer I1 is equal to j and I2 is equal to 0. Both are actually 0, starting of the string 1 and string 2. So whenever our I1 less than string 1 dot size and I2 string 2 dot size, so both are actually not pointing, any one of them actually not reach the end. If any one of them reach the end means like string 2, I have reached the string 2 end, so that time I have to return true. If I have reached the end of the string 1, that time return false, because we have not reached string 2 but we have reached the end of the string 1, that means we have not found any match, right? So that's why I have to take any one of these actually reach the end, that time break this while loop. Now if it is break, then I what will do, I will check I have reached the string 2 end of the string 2, that is good, that time return true, else return false, that means we have reached the end of the string 1. This is clear. Now what we are doing inside the while loop, so first we are checking if it is directly matched the current character, like string 1 of I1, a particular character at present at the I1 index, that is equal to the string 2 of I2 I2 index, that time actually directly matched, we don't need to do that operation. So that's why I'll just increase both the both actually indexes, both the pointer from string 1 and string 2, because both are actually matched, and continue that. Else it may be possible that the difference is 1, we can actually perform that operation and we can actually convert that to the target character. So that's why we have called this if condition again, like if we check, I can actually call, we didn't need to call the function or not of that operation. So string true, that I2 index, and the difference between this string 1 from I1 index, that is equal to 1. That means after performing at only one operation, we can actually convert this to a target character. So that's why I will increase both the indexes of the string 1 and string 2, both are increased, and continue. But here actually I have handled in some situation. How? Like if I do this condition, like if I have suppose z from the string 1, z from string 1 and string 2, I actually have a. So they mention that if I call the cyclic operation on this, so z will be converted to a. Now here actually generalize, it is okay to a to b, the difference will be 1, b to c difference will be 1, d to e difference will be 1. But for this situation z to a, the difference is not equal to 1. This is clear. You can check a ASCII value is 0, suppose z ASCII value is 25. So if I do the 0 minus 25, so this will give the minus 25, not equal to 1. So that's why I have handled this in a different way. Like I'll check if the string 1 character is z, string 1, that we actually calling that we can actually perform that operation, that is z, and the current character in the string 2 target character is a, that time we can actually perform that operation. So I will actually increase both the indexes and continue from that. Got it? Any other situation is not possible, like string 1 character is y and string 2 character is a, that is not possible to convert, right, to the target character. This is clear, because the difference will be not 1, and it will give us the like 0 minus 24, this will give them 24. This is anyway okay, not equal to 1. Okay, and if none of this is matched, that time only increase the I1 means the string 1 pointer, because this current character is not possible to part of the any subsequence, so that's why just increases I1 plus plus. Got it? So here is the time will be what? We are just traversing the string 1 length and the string 2 length. So n1 plus n2. If the length of the string 1 is n1 and the length of the string 2 is n2, then time will be n1 plus n2, because we are actually index by index we are just traversing. So this is clear. That's why the time will be linear time velocity. It will be ultimately space velocity big of 1. We are not taking any variable, only two integer variable I1 and I2. So this is clear how actually optimize this. This is a 2 pointer actually the algorithm here actually I have used. If you actually, I have already shared the code in the description, you can take the help from that also. And if you have any suggestion, you can comment on that, and please subscribe the channel if you not yet subscribed. Thank you.